This is the Amp Hour Podcast. Released September 25th, 2022. Episode 603. An interview with Ozzie. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
I'm Ozzie. I'm currently CEO of Blues Wireless, but I've been in the industry for a long time.
Hi, Ray. How are you?
I'm very well, thank you. Good to be here, Chris.
Yeah. So in preparation, I got my Blues Wireless board out, and it is just to give people a small word picture of what the board I have is, because you guys have actually introduced a couple since then.
Mm-hmm.
This is a maybe one-ish by one-ish inch cellular board that plugs into an M.2 connector, and then interfaces your board to the rest of the world through cellular.
Yep.
Could you tell us a little more about, is that a good description of it?
Absolutely. I mean, what it is it's a very small cellular module. Somebody might look at it at the beginning when they see it and say, well, it's just a modem or it's something like a modem. But really what it is it's a new composition of function that is supposed to enable developers, hardware engineers, firmware engineers to kind of treat cellular as a data pipe as opposed to kind of the mystical nature of, what it is right now. Currently people have to deal with AT commands and crazy things
Have
to do.
You mean get to?
Get to.
You mean I get to dig through a PDF of 14 different module vendors who all have their own custom AT commands?
Exactly. I mean, we can get into it, but basically, I had a personal experience with a nonprofit post Fukushima that gave me a much closer to the metal understanding of the impediments to this cellular IoT future that we've been talking about for so long. And essentially, I took it upon myself to kind of ask the question: what could we do if there were no limits, no constraints, to make things easy for developers? Both designed for scale, economic scale, manageability, but make it very easy for hardware developers to kind of put a cellular data pipe into their designs, so that all they really had to think about was what they were building, what kind of data needed to be sent to the cloud, inject it into this little data pump.
Data pump.
That's sure.
That's the one I've been seeing on the copy lately. I actually do like that. I think it's a good descriptor.
Well, people want a very simple analogy, and it really, I think if you spoke to any of the developers who've used it, it kind of fulfills that promise. You have to worry about what kind of device you're building. You have to worry about what you're going to do on the cloud side with the data when it comes in, but what you inject into the note card via I2C or USB or UART appears, in your cloud, and there's very little you have to manage in between. It's an infrastructure as a service product that's supposed to be something that hopefully developers will grow to love.
Yeah, that's great. And so the project you were mentioning was Safecast,
Mm-hmm.
and actually two past guests of the Amp Hour have also been. So Akiba, who's been on the show a couple times, I think he was working on Safecast, and
Yep.
I believe Bunny Huang was also working on Safecast.
Absolutely, at the very beginning, absolutely. Essentially, this was March 2011. Many people in the tech industry, I'm sure outside the tech industry also, but I'm very close to a number of people in the tech industry. And whenever there's a natural disaster, people just wanted help. They don't know exactly what they can do or should do, but they want to band together and help. And a group of I'll estimate about 30 people gathered in Tokyo first week of April of 2011, and just tried to decide what we could do. And at the time, this was a week or two after the meltdowns people were being relocated from point A to point B without really being told why. People throughout Japan and throughout the world were wondering, am I safe? And there were really no numbers being released on the ground. The government had its hands full. The power company, TEPCO, had its hands full trying to cope with the disaster. And we kind of came to the conclusion that the best thing we could do was to measure data and publish both the way that we measured the data and the data itself without saying, is it safe or is it not safe, but publishing it in a
Right,
way that
right.
was open data that let people who really knew what they were doing to help citizens understand and appreciate the threat. And it's a great project. Initially, by the end of the first week, we just went to Akihabara and got a commercial GPS unit, used somebody's laptop, borrowed a commercial Geiger counter, and drove through the exclusion zone and started to cover as much territory as possible, correlating time, location, and radiation reading, and publishing it in little segments. You can call them journeys or trips. But by uploading those segments from SD cards, which they were initially written to, a map started to take shape. And you could see very clearly on the map, and you can go there today at safecast.org, go to the map, and you can see that a plume had gone kind of northwest from the plant. And sadly, we learned that people were relocated from safe areas to unsafe areas because people didn't have that
Right.
big picture. And so a number of us just said, look, let's set this up as a nonprofit and as something sustainable based on citizen data, to try to set a baseline even elsewhere outside Japan, so that if something else ever happens, we have a baseline and we're prepared very rapidly to deploy devices and deploy the know-how that we had built up at that point in terms of measurement.
Yep. Yep. And I imagine, I mean, 2011, I think about like even 5 years ago using cellular stuff. That's kind of when I got started into it, and it was kind of rough.
Yeah,
And I mean, seven
yeah,
years prior to that, and 7 years prior, like just
yeah,
so it's post iPhone start, but in terms
yeah.
of availability, and I guess it would have been what, 2G, 3G at that time.
It was quite an interesting journey. I mean, I had done hardware probably from 10 years old through college. I was a double E major when I went to University of Illinois, but I switched to software early on, and I hadn't soldered a thing, until the first months after we had started. The initial things that we were trying to build were based on simple Spark Fun, Adafruit, Seed
Mm-hmm.
Studios,
Yep. Yep.
modules.
Yeah, like the Simcom 811s or 810s or whatever those are, 800s.
Actually, at the very beginning, there was no cellular service in the area,
Oh
so
wow. Okay.
initially we recorded data on SD cards, but the first devices that were wireless, we tried LoRa,
Uh huh.
and I built a little LoRa concentrator based on what was at the time Resin.io, now Balena,
Mm-hmm. Yep.
management of Raspberry Pis. And then we built these things called SolarCast boxes, which were essentially solar powered with dual particle counters for air quality, dual Geiger counters, and LoRa backhaul and we were fortunate that we found a way to get these solar powered devices brought into the exclusion zone. We had access one day a year because people who were sent away outside the exclusion zone were allowed to visit their homes once a year. So initially we were backhauling by LoRa. As the cellular service came up, that was something we were looking forward to, because building your own LoRa network can be challenging, especially in
Mm-hmm.
hilly
Yep.
environments. And initially I went for Adafruit Phona modules, and they worked really well. It was 3G. The challenge, though, was every time we tried to prototype, we could never meet the current budget goals
Yeah.
based on the
So,
solar panels. We had these beautiful voltaic solar panels that were generating a lot of energy, and nice battery packs that were storing them. But the cellular, whether it was connecting 2G or 3G, it was probably a 2 amp pulse
Mm-hmm.
at the beginning.
Yeah, GSM is unforgiving
It
in
was,
that way.
yeah, and you didn't know what you were going to go, what network you were going to hop onto when it came up. And so basically I stepped back and said, how hard can this be? Even not having done any of this work in a long time, I started with a Nordic NRF 51 chip,
Mm-hmm.
thinking that if somebody's doing something with Bluetooth, they must have a decent firmware stack to let the firmware at least sleep, and started going through the journey of trying to deal with PSM on the modules, realizing that it was a pain, and I couldn't achieve the current budget that was in the data sheet. So, I just stuck a low side end channel MOSFET in there just to shut the power off to the whole modem to completely.
Mm-hmm.
Then we started to have to essentially write the firmware to measure what kind of voltage was in the pack, modify the measurement frequency and the upload frequency based on the available power. And eventually we did end up with a really great device that did operate in a standalone way and have been very reliable over time. But it was a real learning experience for me because I just did not understand the complexity of both doing what I was familiar with, which is essentially state machines, programming of state machines based on all the knowledge at my disposal, but dealing with controlling sensors and controlling cellular, realizing that this was going to be a multi-module world, that just because we could deploy that module in one region, it didn't necessarily work in another. The AT commands were different for each one. The
Yep.
carriers,
Yeah.
if we didn't want to operate stealth, the carriers required us to do PTCRB certification, of the modules, which brought in a whole different set of challenges. The cellular plans, we had to deal with local use of local carriers and temporary roaming versus, whereas what we really wanted was permanent roaming, where we could build the devices in one place
Mm-hmm.
and just deploy them where we wanted. Anyway, many, many, many different challenges. And so where the note card, really just emerged from was, after that project, the concept of, could we really make a completely different developer experience, both hardware and software developer, where the hardware developer could not worry about cellular data plans and things, that they could just get a cellular card from a distributor, from a DigiKey, Mouser, Avnet, whomever, treat cloud connectivity as part of their BOM, and just assume that as soon as they plugged in, it would work and auto self-provision and be good for 10 years, and that it would work anywhere. Once you start building it, there are constraints. It's not everywhere. It's where there's coverage, and
Sure.
137 countries, not every country.
207 or whatever the current count
Yeah,
is. I feel
yeah,
like it kind
yeah,
of shifts around day to day.
yeah. But it's a great solution. I encourage people to try it out.
That's great. I would love to. So up until this point, I think the story. So the story you're telling here, the
Hmm.
struggles you went through, these all sound very, very familiar to me. All of the certifications and the various options that are out there. But I'd love to
Hmm.
blow a couple people's minds here who haven't heard of you before. Could you explain what you were doing? Let me just look on your LinkedIn thing real quick. Around 2005, what you what you took over doing in 2005.
Sure.
Just going back in time here a little bit, just to give people context.
Yeah. So 2005, I'll give the story before that in a minute, but 2005, one of my startups, I've done, depending on how you count, 6 or 8 startups. One of my startups was bought by Microsoft, and I was asked, Bill Gates, who I've known for many years, probably since '82, asked. He told me that he was thinking of leaving to start a foundation with Melinda, and he wanted to devote full time to it, and asked if I would take over his role. His concept was that I would divide his job with another guy by the name of Craig Mundy, great guy.
Mm-hmm.
And Craig would take over all external facing, outside facing aspects of his job. I would essentially give inward guidance that I felt was appropriate to the development teams and try to steer the company forward. And my view at the time was that the biggest single challenge that Microsoft had was that it was a box company. It made servers, Xboxes, PC operating system, and that it had to kind of shift to a world of services. So I took over Bill's job as chief software architect and tried to shift the course of the super tanker by a few good degrees.
Yeah, yeah,
And
yeah.
it was quite an interesting journey, and so it essentially laid the groundwork for many of the things that you see today that are connected versions of what in the past were not connected, and had a pretty direct role in initiating the Azure project.
That's pretty cool. Yeah, Azure. I've heard of that. Yeah, that's really great.
Yeah.
And I have to say, between you and Craig, I think you got the sweeter part of the deal because you got sounds like the fun part. I mean, not easy by any stretch of the imagination, but Craig's probably talking to shareholders and dealing with stuff like that, and you're getting to talk to engineers.
Depends on your personality.
Yeah.
Craig it loves Bill is Bill would fly from country to country and meet with ministers
Oh
and
my, yeah.
obviously deal with customers. I am an engineer.
Mm-hmm.
Engineer. I'm a little bit more on the introverted
Mm-hmm.
side,
Mm-hmm. That
and
sounds familiar. Yep.
yeah. And so
Yeah.
I enjoyed my site.
That's great. I mean,
Yeah.
culture shift wise, that must have been just crazy. Like, I mean, I think about Microsoft in the old days of just like, no, you buy the hologram sticker that goes onto the back of the PC when you buy the PC, and like that was just like that was the cash cow, and then it's like Azure is just monster. It's just
Yeah.
the monster. It's AWS and Azure are the two monsters basically. It's crazy.
Well, it was a pretty strange, surreal experience for me because I'd spent most of my career competing with Microsoft.
Yeah.
I had, when I first entered the industry, back in the late '70s, I started in operating system development at a company called Data General back in the day. I could see that this microcomputer thing was going to be something. So I went to a small company in Cambridge called Software Arts, about 29, 30 people at the time. They worked on a product called VisiCalc. And so
Mm-hmm.
my first job there was porting VisiCalc to the TRS 80
Mm-hmm.
Model 3.
Yep.
Great
See, now
little.
I'd like to pause on that as well because this is
Sure.
this is an interesting like software time too, where like you're writing software, but like man, you must have been so deep in registers on the actual chipsets on the TRS-80 because it's not like today with
Oh, yeah.
there was an OS, but it was more custom to each build. It was not the same world at all.
No, it wasn't. And I started programming back in '69, on a GE 400, mainframe computer,
Heavy iron, yeah.
time sharing. But when I was in college, I was an electronic technician in Department of Nuclear Engineering. I built little devices for grad students, and
Mm,
they brought in one of the guys brought in one day a 404 Intel 404,
mm,
and then 8008, then 8080, and we would just have so much fun with these things,
yeah,
building, integrating them into people's experiments. Of course, it was all assembly
yeah,
language, and yes, you're dealing with, there's no OS. You're just bootstrapping it, just like at the time you would bootstrap every mini computer by
yeah.
that you dealt with by typing, programs in with switches. The same thing was true with the 8080s, and I think at the time I did VisiCalc for the Model 80, it was a Z80.
Okay.
But in any case, I did that. I had essentially, while I was there, ever since I left school, I had wanted to start a company with my friends to do something that had not been seen at the time, which was a collaboration system where computers were used as communication terminals, but we were still in a microcomputer era, and there was no networking between these microcomputers. People were just
Mm,
becoming enamored with spreadsheets. My previous boss, a friend of mine, started a company with Mitch Kapor called Lotus, and they were trying to take down VisiCalc, which I had been working on.
Hmm.
They tried to convince me to go there, and
That's
I said, no, I want to go do the startup. And they said, look, if you just do one version of what at the time was called Lotus 123, just do one version for us. The development group was about 8 people. Then we will get you funded to do what you really want to do. And so I went to the then pretty young Lotus and did a product for them called Symphony. It was about 250,000 lines of assembly language. 3 of us did it. Matt Stern, Barry Spencer, and I. It was an amazing project. 9 months from the first day we worked on it until it shipped. After that, Mitch Kapor, who was the founder of Lotus, followed through with his commitment, a verbal commitment, and said, how can we get you set up with your startup? So I started a company with my buddies called Iris Associates, and we started working on this thing that eventually became Lotus Notes.
which yeah, that hit a lot of people's eyeballs. I think Lotus Notes. I think I was still using. I was looking up the history of this when we talked about you coming on the show, because I used it
Mm-hmm.
still at ABB in 2014. We were still using a very modified version, of course, of Lotus Notes, but yeah, it was still in name at least.
Yeah, it was an amazing experience. And with Lotus Notes, essentially, this was at the dawn of local area networking. The 3Com had just come out with the Ethernet card. IBM had their token
Yep,
ring.
yep.
There were several competing technologies, and it was tremendous. We had no idea what we were doing. We didn't know how to sell it. This was an enterprise product, but Lotus didn't understand what enterprise was because it
Mm-hmm.
was an era of shrink-wrapped software that
Uh-huh.
you sold at computer
Yep,
stores.
yep.
But eventually it started taking off, and we eventually, after 10 years, were acquired by Lotus. Then Lotus was swallowed up by IBM. And I think when I left, it was probably 120 million users at the
Oh my
time.
god.
But we were competing head to head with this little product called Microsoft Exchange, and
Yes, yep.
we took half the market. They took half the market. We won all of the Global 2000. They won most small to medium business, and eventually they ate up the whole thing. But
Mhm.
my point to this whole thing is, even though I'd known Gates and Ballmer and so many people at Microsoft from the VisiCalc days, because Microsoft was only 30 people
Mhm.
at the time, also very small industry. Even though I knew them, they were the enemy,
Mhm. Yeah, yeah.
and so after I had done another startup, Groove, and eventually they bought that startup, I was the enemy, and so it was,
So like,
yeah.
so like 2020s, let's say, Bill Gates is, philanthropist, major, like, like he's just, and he's got this very soft image, but like, so like, and the Ray Ozzie that I've met and know a little bit, very kind, and is there a past version of Ray that was also like very cutthroat? Was this endemic to the 90s where it was just like pleated khakis and hatred for your enemy in the software world, or what was it?
No,
What was the
no,
old Ray like?
no. The old Ray is the
Is the
current
current
Ray, and
Ray?
I
Okay,
hope
all right.
I hope that you'd
Okay, good, good, good.
find people who work for me, and they'd probably confirm the same thing. No, Bill, anybody who is in a position of incredible success, who is surrounded by people telling you how smart you are all the time, and is asking you to keynote CES and this and that and the other, you I'll just say you grow.
Uh-huh.
He had to scale. He had to at a personal level understand how to go from being the techie CEO of a 30-person startup to somebody who had 70, 80, 90,000 people
Yeah.
reporting to him in a cutthroat competitive environment. We wanted, Lotus had 123. We wanted to take Excel down, or didn't want to let them come up.
Mm-hmm.
In every aspect of it, it was very competitive. And Bill is one of these rare individuals who, particularly rare at the time, who both understood technology, business, and customers and market. And he could he could kind of foresee how you would mix those to create a big company. The companies that were led by pure techies kind of lost
Yeah.
over time. The
Yeah.
people who were pure salespeople kind of lost over time because they didn't understand the business opportunities. So,
Yeah.
by the time I got there, Microsoft, I don't know if you've ever seen that sketch that's out on the internet that has a picture of the hierarchy of Microsoft with
No,
little
no.
guys that are shooting guns at each other, and different tech companies with their cultures. The Microsoft culture was a very divisionalized culture, and there was a lot of internal competition, and so trying to shift that company, towards services was challenging. But obviously, many people stepped up, and that's why the company is what it is today.
Interesting. Yeah. Yeah. I mean, so I'm a little too young to have been in this part of the industry, but my intro to all this stuff, I was really excited to go to the Zephyr Summit, and we get to go to the Computer
Mm-hmm.
History Museum. And because I had just read the Xerox PARC book, and I really didn't have, just to go back a little bit to the kind of software
Mm-hmm.
on microcomputers kind of thing, I didn't have a good feel for like how that process was, and even the lack of networking. It's just like, so I take it for granted every single day, right? Obviously you and I are talking through fiber
Mm-hmm.
optics across many, many miles, and yeah, over audio, and it's flawless now, and it's just so completely easy to connect
Yeah,
over the internet now. And
it's kind of crazy.
yeah,
I know.
and
I know.
so I didn't have a good feel for that on the development side either, and so like that's where it really kind of like your experience doing VisiCalc, doing Lotus, all of the as connectivity was maturing, you were like right there, ready to build these tools that help people along. I could see how that would be very profitable and and cutthroat, like you said.
Well, what helped for me and for my co-founders at Iris was we had a picture from this thing that we had dealt with in college called Plato. We had a little tiny peek of what it was like to have thousands or tens of thousands of users using a single system, creating interactive games, building chat tools, building, electronic forums. We had this picture of the end game already in our minds in the early 70s, well before the internet. And when we left, we all went to system software shops.
Mm.
They went to DEC, I went to Data General. We all worked on operating systems. They worked on VMS and so on. And because we honed our skills in operating systems in very complex code and source management techniques and so on, and we knew what the end game was.
Yeah.
Essentially, what we did is to say, okay, well, how is that all that infrastructure in the middle going to come together? Pre-internet, the only way you could create a virtual image of a unified system worldwide was to somehow weave together distributed systems.
Mm-hmm.
And in that era, the best thing out there was this thing called UUCP. It was a Unix to Unix copy program that would run in the background, at night or, periodically, dial up a phone.
Oh, like an rsync almost, like between
It was
machines.
exactly,
Yeah.
yeah, exactly our sync,
Yeah.
and it would swap news groups,
Oh, awesome.
use news groups
Yeah.
across these different things. And so when you were looking at these news groups or your mail, you would have this visualization that it was one
Yeah.
unified
Like
thing.
chunk of data. Yeah, it's like a mail delivery, almost like a package of papers getting delivered to your house each day, and then you go and parse them.
Exactly. And so with Lotus Notes, we built a system that used PCs as servers and as clients.
Oh,
They used modems. At the time we had upgraded from the 300 baud that it was when I started in the industry to like 12 or 2400 baud.
oh man.
But they would dial each other out. We built what today you call a NoSQL database, and it would do synchronization, bidirectional synchronization of these databases over phone lines. And essentially, the end user had this view of what was going on throughout their organization and so on. And there were other efforts like bulletin board
Hmm.
systems at the time that
Hmm.
were trying to do the same thing. FidoNet was a wonderful one.
Yeah. Yeah, I just imagine how exciting that must have been too for having going from like no connectivity to tons of connectivity. I think the only analogy I would have in my life is probably that same like kind of getting to college experience and then like having this new way of operating. And I went to a school where they had fiber to each room, and it was like internal gigabit network, like just within the campus. Anything external was dog slow. And you know, I should have seen, like, I should have looked at, so like, Ray, you looked at your experience, and you're like, okay, I should go build this company. I looked at my experience and I'm like, oh, look, free movies. But what I should have done is been like, you know, Reed Hastings and been like, oh, sharing movies or streaming movies. That should have, the
Yeah.
smart Chris would have done that. And you know, I'd be atop an empire of waning content, but still.
You know, it's easy to say at any given point in time that it must have been cool back then, you know, because of this and that and the other. And I will just counter with two things. Number one, it was also extremely frustrating
Yeah.
because there were many, many, many impediments, and things took so much longer to mature. You knew where it was going,
Mm-hmm.
but you didn't know how to get there. For example, you know, one of the biggest impediments of getting Lotus Notes deployed within many of the big offices in like New York. Merrill was a big
Mm-hmm.
company now, Merrill Lynch,
Mm-hmm.
and they wanted to bring this thing in, but it was a union job
Oh.
to drill holes in the walls. So it took them probably 18
Oh
months
my gosh.
just to get the LAN installed, even though that's what they wanted to do. And
Wow.
you know, there were just all these impediments. And so today we're standing on the shoulders of each previous
Mm-hmm.
generation of technology. And I guarantee you, every time of my career, every moment has been the best of times and the worst of times. And right now, if you look out there, there is so much opportunity to innovate
Mm-hmm.
based on where things are. I mean, I hadn't coded, I was a developer, and because of success, because of leading
Mm-hmm.
a company that was getting larger and larger, I had to stop coding in 96.
Isn't that heartbreaking? Just how that works.
It,
Like, it's just like
it
the thing
was.
that you love doing, the thing you went to school for, the thing you're
I
passionate
know.
about. I'm sure you've spent, you know, the requisite 10 to 80 plus thousand hours, you know, like whatever the expert level they say is these days. It's just like,
Yep.
yeah, of course you've done that. And then it's like, oh,
Yep.
now I have to go and deal with humans.
Well,
Stockholders.
yep. Some people decide to make that choice. You know, some people I know, like Dave Cutler, you know, at from DEC and who's at Microsoft, he's older than I am. You know, he's still probably the first one at work every day at
Oh, wow.
Microsoft working on Xbox kernel.
Oh, wow.
If you decide to stay technical, you know you can. But at that time, I had made the choice of moving on from that, and I didn't code again until Safecast,
Wow.
until that volunteer project. And I've got to tell you, when I started working on the note card, it was one of these working on something by yourself for 2 years before you start, you know, bringing other people in, and just all of that learning. And it was so great because although the very first thing I did was to start with a Raspberry Pi or BeagleBone and mock things up at a very high level, I knew I wanted to make a little card out of it. So I picked a processor, you know, in my case, it was STM32 L4 plus,
Mm-hmm.
L4R5. And what is the STM32L4R5? It's 640K of RAM, it's 2 megabytes of flash, of storage, a little simple RTOS. It was exactly the computer that I was programming on when I stopped programming.
Yeah. Yeah.
I mean, 640K of memory, it
Different
was the PC.
memory and battery requirements, I think, maybe.
Yes, slightly, but it was like going home again.
Yeah,
I
that's
mean, you
great.
know, I was using Emacs and Make and
Yeah.
just what I did then. But you know, I think each one of us has to find our own balance. I learned probably 20, 25 years ago about myself that I could not have a happy week unless I did something that made me feel as though I was having a broad impact
Mm.
on something,
Mm-hmm.
you know, and I could not be happy unless I was close to the metal
Mm.
on something. And so my whole career, you know, when I was at Microsoft, I had my labs and people, you know, reporting to me who were doing projects like Azure, a thing called Live Mesh. There were probably a dozen of these projects at any given point in time that I was scratching an itch that I couldn't find some other way to realize. And the rest of the time trying to, in meetings, essentially trying to recruit others to the vision that they
Yeah.
should convert what they are doing to a services centric vision.
Hmm.
Uh,
Interesting.
you know,
Yeah.
at the current time, I scratch the startup itch because I've got, I'm CEO of this 50-person startup, but I'm also on the board of Hewlett Packard Enterprise. I'm
Oh,
on a
cool.
technical advisory board of the CEO and his staff at AT&T. So, I kind of try to span both sides.
That's good. Yeah. I mean, I think, so I think there's something in there as well. Like the ability, I think one thing that I look at, your success and, someone that I'd like to emulate, and the ability to have the technical stuff. I want that in my life, but like the ability to convince people to join on a project, or, to jump in on something new and scary and exciting and unsure of things, like that
Mm-hmm.
is a skill that I think anyone listening here could try and work on, because that doesn't just happen at like, just CEO level. It's also like maybe you're starting up a technical study group internally or something like that, but you still have to convince people. And so
Yeah. Well,
as an
yeah.
engineer, how do you, as an engineer, you mentioned kind of introverted, how do you start to do that sort of thing? How do you develop that skill to draw, people into your orbit to build impact?
That is a really, really good question. I mean, I can tell you what it was like for me. I don't know how much of this is a repeatable pattern, but I will tell you that from a very early stage, this was in college. I was fortunate enough to have been exposed to and eventually worked for what I would call a creative eccentric, somebody who's a little bit nuts,
Uh-huh.
somewhat of a magician, somewhat of a salesperson, a deep engineer. And the first one was Don Bitzer, and I'm very fortunate. I'm a computer history museum fellow.
Hmm.
I'm going to be inducting him
Oh,
on
wow.
October 14th. It's really great, but he had this vision for how computers in 1968, how computers could be used to change the art of teaching, and how it could be used. How computer based education or computer assisted learning could potentially be very transformational. There were no big systems at the time. He managed to convince he and several others, but he was the leader. He recruited a bunch of people. Every single time he found a technical roadblock, he, being an engineer, being a physicist, being a magician, he found a way to get past that roadblock. So, for example, at the time, storage was
Oh, yeah.
incredibly expensive,
Yes.
and the only way you could actually get an image on that you could look at on a terminal was to use a storage tube. That was the only economically viable way. And he envisioned that thousands of students would be using graphics terminals. So he said, how can I get these images to be retained on a display and make the display cheap enough that we could put them in terminals?
Yeah.
So he invented the plasma panel.
Wow.
And so what Plato was is they were terminals with 512 by 512 individually addressable dots on the screen, with an integrated modem, with an integrated fiche projector that you could digitally select which of 256 slides to project on the ground glass on the back of the plasma panel, with an audio device, with synchronized audio to the vision. He just had this vision and he did it, and he inspired people by telling stories, and we
Yes. Yes.
absorbed. I was young. I was in college, and you just wanted to be like this person because he could accomplish anything. As my career progressed, I just gravitated toward these people. I had the opportunity to meet Doug Engelbart, and I didn't work for him, but
Wow.
he had this vision. JCR Licklider had this vision of communication. There were all these people who would have this very romantic vision of the future, who might not be able to execute it, but boy, that's a project I want to work on.
Uh-huh. Yeah.
And so, my recommendation, would be, you can't just become that person overnight, but the more you put yourself into a situation where you are supporting the risk taker, realizing that risk taker's vision, seeing how that risk taker balances execution and promotion, because they're all necessary. You have to, you always have to do something that is outside your comfort zone, maybe potentially unpleasant, speaking in front of people, raising money. The best part of it is feeling like you're part of an exciting journey.
Mm,
It's this classic thing, change the world. Not every project has changed the world, but you can have a really great vision of what you are trying to change. And I would just say, attach yourself, to those people, and you will become them.
that's great. Yeah, I think that storytelling aspect too. I mean, obviously you're doing that right now. I think you're doing a very great job of it. Like the storytelling. I'm actually reading a couple of different books about like kind of storytelling as an art, just because like humans are so primed for it. That's like
Hmm.
prior to Lotus Notes. That's how we got the point across.
Exactly. Exactly.
Yeah.
Yep. Yep.
That's great. So let's go back to blues is your current thing.
Yes, sir.
You've mentioned you have a 50-person strong team, which is awesome.
Yep.
What where's that all going? Maybe actually talk about the it's not just cellular anymore. So what are some of the other things that you're building?
Well, let me just step back. What I was amazed by when I was working on the Safecast project was that I had, in developing Azure, in bringing early enterprise customers onto Azure, certainly I knew what IoT was. I think at the time we called it M2M, but machines lighting up and doing things, being able to be remote controlled, doing remote monitoring, tracking, and so on. I knew of all this stuff as an application area. When I started to work hands on at Safecast, I suddenly realized that all of these people who were talking about there being billions, potentially billions or hundreds of billions,
Oh yeah.
they weren't insane. Like this thing, many people ask, how does Bill Gates, how did he become successful, and other people, Jobs and others? If you have a clear understanding of the technology and the technology evolution, you can draw a line to where the technology will ultimately be. And so all you have to do is try to imagine, if the world was born that way, what
Mm,
maybe some potential solutions might look like. And then it's a matter of either building it, or having, patience to get there. But it was very clear that Masa Son, the crazy guy leading, SoftBank, who has been
hmm.
written about a lot. Or if you saw the
Vision Fund. Yes.
WeWork movie,
Yeah.
he talked about this trillion IoT device future, and it hasn't happened. But that doesn't mean he's wrong. And
Sure.
so I started to look at what are the impediments. I do believe, my passion is not on the consumer side of technology. I think a lot of people are doing good things and not so great things, in the way that they're integrating it into our lives and creating complexity that maybe we don't need. But on the commercial side, I believe that there is an immense amount of value that can be created by, instead of just building boxes and throwing them over the wall, maintaining a connection to the customer and maintaining, giving them
Hmm.
feedback about how that thing that they're using is working or not working over time, even in areas where there are multi-tiered distribution chains of getting products out. Maintaining the contact between the original vendor and the people who are using it, I believe, has immense value. And these everything that you look at when you walk around outside, a generator, a propane tank,
Hmm.
a
Yeah.
stoplight, whatever they are all going to be cloud connected. They just simply will be. And so I am trying to enable that future. And obviously many people are trying to enable it. We are concentrating on the communication domain, because I believe if we can help people to focus on what they're trying to build, and as I said, create this little embeddable data pump, and do it economically, not use it and abuse it. AWS has shown that you can build a really great business around very simple infrastructure.
Hmm.
Yes, they're trying to walk up the stack and increase profitability by moving from infrastructure into PaaS. But if you treat developers well, if you solve the problems that they've got, if you don't abuse that relationship, you can get their trust and maintain their trust. And so, what we're trying to do with Blues is essentially solve a problem that is a real problem, which is getting devices, getting equipment connected by cellular very, very easily. Number two, I believe very much that, because I'm a developer, I believe that you really have to understand developers if you're going to build something that developers love. And you can kind of tell the difference. But you can go, if you go to a site and it says click for pricing, it's not a developer focused site. You want to show empathy for the journey that the developer must go through, because he or she has got a very complicated existence. So focus very much on that, and at the same time have a separate motion where you're approaching product managers or that level within large companies who have 10,000, 25,000, 100,000 unit potential deployments of something, and show them economically and from a security standpoint and a sustainability standpoint that if they bet on this, it's the best way for them to accomplish what they need to accomplish.
Yeah, I think that that's kind of the transformation I've made as well. Like I've in the past, I may have spoken disparagingly about the Internet of Things. If the
Mm-hmm.
Empire is 12 years old now, I've probably said some things across the years, and now I would also work in the space. But what it's come to me, it's like it's all like IoT, Internet of Things, anything like that, M2M, however you want to say it. Like the entire value proposition is just saving money or making money, right? So like at that point, it becomes, assuming you knock down walls in terms of actual implementation,
Mm-hmm.
like it's pretty easy sell. It's like, okay, well, you don't have to do as many stops on your route in order to, because you already know the status of 5 out of the 10 machines don't need to be serviced on your route. And so you're going to save money on fuel and time and stuff like that. Or the status of all your machines out in the field. So you don't need to send you don't need to have as many technicians, or you can do more with the technicians you do have. And just like all of those small things, especially like in the face of labor shortages, like it just all starts to add up and really really starts to make sense. But like you said, in order to implement, you still need it to be easy enough to implement and make it so that people understand they can make money or save money
Yep.
using connected devices.
And I believe in the earlier days of IoT, there was a lot of there were a lot of people talking about the fact that this could be coupled to a change to a subscription model for classic products. What we have found at this juncture is that a lot of people in the early days prototype things using, little ESP32s or, Wi-Fi and this and that. It didn't work out for one way or another, and for one reason or another, and they could not figure out how to modify the business model. The majority of the people we deal with now are now realizing that they just need to embed connectivity into the base BOM and price of the product.
Mm,
And
yeah.
essentially, what they're doing is delivering better features to the customers as a side effect of that. So, for example, if you are a large scale manufacturer of refrigerators, you can offer them at very little marginal cost the knowledge of whether their stuff is going to go bad or not because a power failure happened. It's a very simple thing.
Yeah.
If you don't have this idea that this is going to do this super grand transformation, you can make very material, small, incremental positive changes. If you buy a propane tank, you can know when it's running out, or an oil tank. If you're if you can run things more efficiently, for sure. If you've got a construction site, knowing where the equipment is, knowing how fast the concrete is curing, there are lots of applications of these different technologies. But for each industry, there are people within those enterprises who already know what they're trying to accomplish and don't know how to get from point A to point B.
Hmm.
Consultants are ubiquitous. We need more.
Agree.
People who will get out there and help bridge that gap from the domain expert who knows what they're trying to do, to getting something out there. But it's going to take all of us to eliminate that friction and to get management of billions of physical assets to be as easy as the tool chain is right now, just for cloud developers to manage millions
Mm.
of instances up in the cloud.
Yeah. I think that does kind of touch on. So, like, prior to my own journey into the IoT space, I think I was kind of just hesitant on, like, well, I don't know any software stuff. So maybe can you run us through, like, so someone's using Blues, they decide to buy a note card, they design into their product, they understand all the hardware aspects, but then, like, okay, let's just make up a fake product here. They've got a PIC 32 that's doing some industrial process. They're like, I want to make this cellular.
Yep.
Now they decide, they do it with board rev, they put an M.2 connector on there. They've already prototyped with the node card. Now they have a node card in there and it can talk cellular.
Mm-hmm.
So then what changes about their embedded code? And then what changes in terms of what they have to actually do on the cloud side? Because I think that was the scary part for me when I got started into all this.
So it all depends on whether you are thinking about a new product or a retrofit. And let me just walk through a retrofit example. In many cases, and this was not planned, this just ended up being this way. When we did Notecard at the beginning, we had a view of how to make a very seamless developer experience, primarily focused on new products. But it turns out, once people have it indoors, in-house, and they see the power of it, suddenly they realize I can retrofit 1 million units that are out there already. So I'll give you one example, a concrete example of somebody. I went to visit a potential customer. This is very early days, and this was someone who had an MSP 430 plus an FPGA. It was just like a very small. Yeah. It was a device that had already been built. But it was.
I'm going to save all this power on the MSP 430, and then I'm going to put an FPGA on there.
Yeah, but even the MSP 430, it had I think it was 32K. It was very low power.
Oh yeah.
And they just wanted to get the result of the machine learning that was being done by this thing, and they had already started shipping a ton of these units to people. How can I get this cloud connected more easily? They had started prototyping Wi-Fi, and cellular was needed. So what we did in an hour was the guy added 2 printfs to his code, and you could do it with printf or an Arduino serial.write or something like that. But essentially, you put together a text string that is a JSON text string, and there's one text string that you would need to configure the note card, meaning you say to it, I am product ID X, and I'll come back to that because that's how it finds its way to the cloud. I am product ID X. I want to synchronize over cellular once an hour if there's data pending once an hour, and that's it. And then and so you just put a little JSON object with 2 fields in it, and you send it out. You just printf it out the serial port. Then once every time an event happened, they would create in memory another little JSON object and format it up in a buffer and just send it out serial. And that was it. That was the whole thing. And it was good. It sounds too simple to be true, but it was good enough to ship, meaning our module is pre-certified. It's already, it does TLS. It already does firmware update of itself, and it can do it of the host firmware. It's an extremely simple thing, but there is this really low bar if you just want to start seeing how you can get. Let's say you're building some equivalent of the classic mousetrap. All you want to do is report open or closed. And for something like that, all you have to do is hook it up to a serial port or I2C. On I2C, we have a serial over I2C, very simple protocol. So you're doing the exact same thing. You're just sending it over I2C if you don't happen to have an extra UART lying around. And that's it. And if you look at all note card applications, they essentially start with that simple model and move up from there. So, for example, the note card has on it a modem, a GPS, an accelerometer, a SIM, a secure element. It's got all these things, but it packages them all as these simple little JSON commands. So if you say, what is the orientation? I am face up. I am lying on the back. Okay, then it serves an application where they can just slap this thing on the back of a road sign and find out if the thing got knocked over, for during
Mm-hmm.
construction.
Sure.
For GPS, I could build a very simple tracking application by having it report to me changes of location, and it uses the accelerometer so that you don't have to power up the GPS if the device has not moved. Essentially, there are all these little things, and so the developer experience is you start by going to dev.blues.io, and you can start to look at the vocabulary of these little JSON commands. We have a REPL. It was funny because I listened to your show where you covered WalkWe.
Oh yeah, with theory. Yep. Yeah.
The concept of having hardware simulation behind a web page is an extremely powerful concept, and you can do everything that you would do to a note card directly in a REPL on the website, to practice to understand how you would build your app. And then, if you order the hardware, you just hook it up to USB. We use Web Serial to enable
Yeah.
you
Yeah.
to.
I did a training with Rob at when he was in
Oh,
North
that's great.
Carolina. That was yeah. It was really that's the hardware I have actually, and it was like super fast to get started. You plug it in, you just
That's
start
great.
talking over the USB.
That's
It
great.
was really slick.
But
So
at a high level, the thing to think about is my goal. To me, success is the simpler the app, the better. The more complicated the app is, the longer it will take to ship. The people who are focused and saying these are the 3, the 4, the 5 pieces of data that I want that I need sent up to the cloud, they can get those devices spun very quickly using our note carriers, spinning your own. It's very simple. And then to your point, what they have to do is they or their buddy, their pal who understands the cloud tool chain.
the Web Pal. Yeah, I know the
Yeah,
Web
the
Pal,
web pal.
the Cloud Pal.
All you have to do is use standard. You don't need an IoT platform. We inject it into your web app using standard REST APIs. So the JSON that you put into the note card comes into your website as that same JSON, decorated with other metadata fields of what is the cell tower location, where it called in on, what was the voltage of the thing, what was the RSSI
Hmm.
of the, we give you all sorts of information, that we have, that we're able to ascertain from, because we wrote the code that's wrapping the modem.
Yeah.
And then you just have to you have to do what you're going to do on the service. We are not an end-to-end solution provider where we provide the glass. Our core customers tend to know what they want to do with the data and have it injected into their systems, whether it's their customer support and service systems, maintenance systems. Some of them just have it drop into Snowflake and they do an analytics on it there.
What do you mean by we don't provide the glass for people that don't know that
So
reference?
we do not. There are companies, great companies like Samsara, who sell solutions. They sell you a box for tracking, and then they sell you a
Hmm.
website, and you do user registration, and it's a SaaS, software as a service offering, where you will go to their portal, you will see where all of your assets are, and so on. It's a complete end-to-end solution.
Hmm.
We
Yep.
are, again, think of AWS. We are hyperscale cellular IoT. We are an infrastructure component that you embed on your board, and you will get your data in the cloud. And it's up to you or your partner to build the app that is appropriate for what you're trying to do. If you're managing moving assets, you might want to see them on a map. If you're managing fixed assets and temperature, and you're measuring vibrations in a compressor, or whatever you're doing, it's kind of up to you or your
Hmm.
cloud people
Yeah.
to build that aspect of the app.
Yeah, I've been using Grafana quite a bit lately. That's
Yep.
how I've been doing. It's open source, and I'm visualization. I'm getting a little better at it, and like you can build whatever you want, but it doesn't mean it's easy. And so you need to talk to something like a REST API.
Yeah,
You know.
it's an extremely quick way of getting
Yeah.
things up and running. Some people want to just have it injected into Postgres or into some other simple time series database and then hook it up to Grafana for visualization. It's really great. That tends to be the kind of thing that people do if they're say 25 people or 25 devices. It's a
Yeah.
quick, an amazingly quick way of getting gratification and getting things up and
Right.
running. People who do things at scale, and as I said, we're kind of a hyperscale
Hmm.
cellular IoT. We're easy to use at the low end, but I am not doing my job if I don't scale to the levels of an Azure or whatever. And when you do things at scale, you need a user interface to manage devices at scale. You need ways to manage a large quantity of
Yeah,
data and so
right,
on.
right.
Yeah.
I think at that point too, you're going to have, if you have a million devices in the field, you almost certainly, well, if you don't have a cloud team, you're probably struggling, but you almost certainly have a pretty sizable cloud team, app team, all of the things that, you think about commercial applications are going to have in
Yep.
that way, because you need to have insights at all different levels. And so you're going to have software people at all different levels as
Yep.
well. So yeah, totally agree.
But I encourage people to look at it because
Yeah.
it brings hyperscale economics and usability to one person projects. It's
Yeah.
very easy, very approachable.
What are the relative scale of costs for a note card? So if someone is listening to this, they're like, okay, well, what does it take to get this onto my board?
$50 is the price of the note card. You can go and get it, right on the store at blues.io or go buy it through DigiKey. But it is $50. That $50 buys you the note card, and the data is embedded on the note card. So you have 500
Yeah,
megabytes of data and 5,000 what we call consumption credits, meaning as the data is routed through our cloud router, the thing that the note card talks to, that's called the Note Hub. For every little event that flies through, it's called a consumption credit. We bundle prepaid consumption credits and data in with the note card. So essentially, for a large number of applications, you'll just buy that thing and put it on the board, and you
yeah,
won't have to pay a subscription, to anyway. It's kind of
right, right.
prepaid. If you exceed, those volume requirements or the data requirements, we have these connectivity assurance, plans where it will auto recharge, either the data or the consumption credits. But it's 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 quite a bit of data. We have
Yeah,
very few customers, very few for whom the 500 megabytes isn't good. I mean, because I am of a certain vintage. I come from an era where we used modems,
yeah. I was
and
just say he's about to talk about bit packing here. I think like
yeah, yeah,
everything's encoded, everything is tiny.
yeah.
Yeah, it's
Everything is
yeah,
extremely tiny. I mean, it's
yeah.
the luck.
What is a good guideline for someone? So like say I'm like so say we're going back to that pick 32. I just want to log like from a local variable. I just want to log like a state, like whether or not the machine learning model has triggered or not, and then maybe a temperature. How
Yep.
many times per minute could I do that for to last that 10 years and the consumption credits?
It's a really good question. You have to kind of do some math.
It depends. It depends.
No,
Of
well,
course. Yeah.
no, I'll tell you what depends. The biggest
Okay.
variables. So if you set up, I'm going to get technical for a moment. If you establish a TCP session, if you connect the note card to the cloud and it's
Hmm.
authenticated over, or sorry, it connects over TCP/IP. It's
Hmm.
just under a K, between 750 and a K bytes of overhead just to make that connection. It's just the
Yeah. Yeah.
nature of protocol setup. If you are connecting and you want a secure session and you're using TLS, the TLS key exchange is just under 4K. It's between 3K and
Mm-hmm.
4K. So if you care a lot about on-wire confidentiality and you
Mm-hmm.
want every session, encrypted, and you don't want to be connecting and then hanging up, so to speak, once every minute, because
Yep.
you're
Yep.
going to
It's
blow
power
through.
intensive.
Yeah,
Yeah.
it's power intensive, and you're going to blow through your data plan, because if to send 10 bytes of data, you're wasting 4K. So if you are a power miserly application, what you want to do is write a lot of things to the note card, do a lot of measurements, and let them queue up in flash memory on the note card, and ask yourself, how often do I really need these in the cloud?
Yep.
Could
Yep.
I do
Yep.
once a day? How about every
Yep.
12 hours? How about every 6 hours? By packing them together, we compress them heavily, and you're saving on the session overhead. So, generally, just a rule of thumb is, if you have, say, a dozen measurements and you set it to connect in its normal mode of operations, you're talking maybe 400 bytes
Okay. Yeah.
of complete end-to-end traffic above the 700 or so for the session setup. So you just kind of do that math, and we have calculators, that'll do it. People who have power connected to their modules just tell it to connect to the cloud constantly. There's no penalty
Right.
for that. You
Right.
just
Yep. Yep.
suffer the session overhead once, and then just leave it connected, and that's fine too. But we
Yep.
have some customers who are sending data once a second, once every few seconds. We have many customers that are doing things once a day.
Yeah.
It
Yeah.
it just depends on the application.
I do like the idea. So, like, the queuing is something actually I did want to bring up, because that's an interesting parallel to how you were talking about, like, as you were moving from 300 bits per second to 2400 bits per second, and like the idea of Lotus Notes going and grabbing this big chunk of data and then like processing it. It's
Mm-hmm.
kind of an analog to that, of, right? It's like you're just queuing up all these packets, making a quasi mini database. If you think of sequential JSON packets as a mini NoSQL database, which I realize it's not.
It may not be a surprise that the reason it's called the Note Card and the Note Hub, and it was called Lotus
Aha.
Notes, is that the core synchronization and communication algorithms, all the core data structures, are modernized versions of exactly what we did in those days,
Oh, that's
because it
great.
was super reliable,
Yep.
it worked, and it
Yep.
occupied very little wire bandwidth. We didn't have it
Yeah.
at the time, so why not
Yeah.
just use it?
It is interesting too, thinking about, like, cellular connection, and really just thinking about IoT in general, like this. You have a pipe to your device, but you have no guarantee it's going to. I mean, you have guarantees it's going to get there, but like you have to think about it as like this kind of time invariant,
Mm-hmm.
or maybe time variant. But you have to basically imagine that you don't have any guarantee of like deliverability at a certain time unless you do a lot of extra things on top of it.
Yep.
So like then that actually changes how you operate as well. Like you said, you might queue up 12 readings to save data, to save power, but then like that actually changes the nature of your monitoring as well. And then you have to set up alerting, and just like
Yep.
there's a lot of other like nuance in there that's like really interesting, I find, and not intuitive either. It's like once you run into it, you're like, oh,
Yep.
oh, now I get it,
Yep. No, it's actually very cool and very simple. When you look at it, you will see that there are two core paradigms. One is the queue, and those can be bidirectional. The other one is the database, meaning we call these things notes. So you add a note, you delete a note, you remove, and so on. So
Hmm.
when you queue a note, you give it to it, and it will sit on the note card until the next time it syncs, and it will compress all those things together. If you put it in a database, we call them note files, it will bidirectionally synchronize with the server copy of same. And so for things like configuration variables, where you just want to set an environment variable on the server and have the whole fleet or a subfleet pay attention to that variable just synchronizes down into a little database, and you can just read it with the same simple little JSON commands. It's a very
Hmm.
scalable
Yeah.
paradigm.
Yeah. Yeah. That's
Yeah,
great.
yeah.
Yeah. And I would encourage people too not to get too scared of JSON. I was very scared of it at first for some reason, and
Mhm.
it's not that bad. It's just a hierarchical list.
No, no, it's really easy. It's just a simple text format of strings and numbers and
Yeah.
true false.
Just don't
It's really
forget to
easy.
escape before your quote marks. That would be my thing, because that's bitten me a couple times.
Yep.
Always escape before your quotation marks.
Yep. Yep.
So Ray, you have shown throughout your career that you are very prescient in terms of what's coming. You're building what's new, what's next. Can you give us a little of that future magic here? What's 5 years out? What's 10 years out?
While many people right now are, how can I say this, focused on the metaverse and focused on Web3 and focused on this and that. Not to say that these are not worthwhile things for people to be
you're
focused
you're in
on.
good company here, Ray. Don't worry. we think it's BS too.
Yeah, I actually believe that the thing that I really want to happen, the thing that I really the change, the dent that I want to make is realizing this tens of billions or hundreds of billions of device future. And I think what's going on, if you look at the landscape of where innovation is happening, I don't think people are giving enough credit in two very somewhat related dimensions. One is wireless in general. There are many different protocols that are happening. If you can go up the unlicensed stack into what's
Yep.
happening in Wi-Fi, Wi-Fi 6 and beyond, you can go into the licensed world and what's happening in 5G, what will be happening in 6G. There are all these sub protocols of 5G red cap, which is reduced capabilities. There are lots of
Mm.
innovations that are happening there, and getting those innovations realized and delivered to developers is incredible. The other innovations that are happening are, and I'm sure you have a lot of exposure to this, is on the MCU side. The
Yep.
integration that's happening and what is going to be in a SIP in
Hmm.
the next several years is kind of mind blowing. I mean, we've seen recently a lot of sophistication of ARM-based processes. You've got the beginnings of RISC-V,
Yeah.
happening. People are now building little things that will have an MCU, a modem, a SIM, a an iSIM, a secure element, several neural processors. If you
Yeah.
need
Yeah.
to do inference, it's extremely powerful, and it's going to really change the game of the kinds of things that we can build. The reason I believe so much in our architecture, where we've kind of separated the telecom from the compute innovation, is I believe you're going to want your choice of MCU for a given application. Oh, this is an analog application. This is doing a lot of edge ML. This is doing, you want to tune and optimize your choice of MCU. At the same time, there's also innovation happening on the telecom side. And over the lifetime of a device, you may go through 2 generations, 3 generations of different cellular or other
Yeah. Right. Right.
things. And I believe LoRa's got a great future too. I mean, there are 4 wireless stacks that have won, and Bluetooth, Wi-Fi, LoRa for wide area, and cellular for wide area, and each one is finding its sweet spot. LoRa
Hmm.
seems to be finding a sweet spot in smart city and agriculture applications. I mean, it's got many possibilities, but very very low cost, large numbers of X. Whether it's lighting or something. Laura is really hitting its mark. Anything in motion or anything that where you don't know where the product is going to be lit up, where you're not the one controlling the deployment, cellular wins, and everything's
Yeah.
going to be cloud connected. So I'm super excited about that.
That's great. Yeah, no, I think this. I mean, it is. It's like it's exciting to be in this part of the industry. I think what I always encourage people to just try and take it one step at a time. Like getting a note card board and carrier. Like I think that's a great way to get started in this sort of thing.
Hmm.
Learning new, taking classes, learning new real-time operating systems, things like that. I think there's just a lot of stuff to learn
Well,
out there,
and go to the
especially.
forums and chat with other
Yeah.
people who are going through the same thing that you
Yeah.
are.
Yeah.
You know,
It's true.
when I was in the 2 years that I said I was trying to figure out how to get the note card built, I didn't know this stuff. I didn't know if I should start with Nucleo
Mm.
or Nucleus as a real-time operating system, or this or that. I ended up with FreeRTOS. Each time I had to make a decision, I had to figure it out, and the only way you learn that is by finding people to talk to. Go to a meetup, get involved in a Slack discussion or a Discord discussion or something with like-minded people. Try to build a project together and solve a problem. You always end up coming out knowing more than you did going in.
That's good advice. Ray, where could people find information about you, about your company, about your past? Where could people find you online?
You don't want to find out about me. You want to find out about the company.
I think you're
The
pretty
company.
interesting. I'd say this 80 minutes we've been recording is pretty proof positive.
Well, I am Rozzy at a not very active Twitter account
Okay.
and LinkedIn as Ray Ozzie, and Blues is really where it's happening. It's blues.io, but for this audience, dev.blues.io.
Yeah.
It's a great thing. Go to the shop, buy a little starter kit, buy a Feather starter kit or a Raspberry Pi starter kit, and just start messing around and scratch some itch. And we would love to help you in the forums. There's a very active forum where we or somebody else in the forum can help out. We'd love to chat with you.
Awesome. Well, thanks so much for joining us in the AMP Hour and talking about all this stuff. I'm excited to see what's next.
Thank you, Chris. No, thanks for inviting me. I appreciate it.